Welcome to Learning AI Keywords Fast Track. Today, we're diving into a powerful idea called the world model. Have you ever imagined what would happen if you turned left instead of right? Or pictured how a ball bounces before it hits the wall? That's your brain running a simulation, and I can do something very similar. In this session, we'll explore how machines build their own mental maps of the world to predict, plan, and act more intelligently. Whether it's a robot vacuum or a self-driving car, world models help AI go beyond simple reactions. Let's begin our journey into how AI thinks ahead. Let's take a quick tour of what's ahead. First, we'll answer the big question: what exactly is a world model in an eye? Then we'll break down why it's so important, why some AI can only react, while others can actually plan. Next, we'll peek under the hood and see how these models work using three key components: encoding, predicting, and decoding. After that, we'll look at real-life examples like robots and self-driving cars. Finally, we'll wrap up with practice questions, a review checklist, and suggestions for going deeper. This step-by-step journey makes complex ideas easy to follow. By the end, you'll not only understand world models, you'll be able to explain them to others too. Ready to get started? Let's dive into the basics. So what exactly is a world model? Simply put, it's an AI's way of imagining the world. Just like you can picture how water splashes when you drop a rock, it builds a mental simulation of its surroundings. This isn't stored as facts or rules, it's learned through data and experience. For example, a robot vacuum doesn't come with a map of your house. But after cleaning for a few days, it learns that furniture stays put and adjusts its path accordingly. That's a basic world model in action. Another example, in a racing game, an AI driver watches how other cars behave and predicts their turns. It doesn't have a rulebook, it learns patterns. And here's the key: a world model isn't just memory. It's a dynamic engine that lets I ask, what if, questions internally. This ability to simulate makes AI smarter, safer, and more adaptable. Let's now explore why this kind of simulation is so essential. Now, why do we even need world models? Let's consider a self-driving car. If it only reacts to what's directly in front of it, it might brake too late when a child runs out from behind a parked car. But with a world model, it can predict that possibility based on patterns, like someone standing near the sidewalk, and prepare in advance. This shift from pure reaction to proactive planning is huge. Think of it like cooking. A reactive chef waits until the pan smokes to turn down the heat. A smart chef anticipates when it's about to burn and acts earlier. World models give AI that foresight. They also make learning faster and safer. Instead of crashing thousands of times in real life, an AI can simulate crashes in its mind and learn from them. This is especially useful in robotics and autonomous systems. So world models aren't just nice to have, they're essential for true intelligence in unpredictable environments. Let's open the black box and see how a world model actually works. It runs in 3 stages. First, the encoder takes raw input like camera images or sensor readings and compresses it into a simpler form called latent space. Think of it like summarizing a long article into bullet points. Next, the dynamics model uses that summary to predict what happens next when the AI takes an action, say, moving forward. It's like asking, if I walk through this door, what will I see? Finally, the decoder reconstructs that prediction into a realistic output, maybe a simulated image of the next room. If the actual view matches the prediction, the model is working well. If not, it adjusts. This loop allows AI to test ideas in its mind before acting in the real world. And the better the simulation, the less real-world trial and error it needs, making learning faster and safer. This process is at the heart of many advanced AI systems today. Now, where do we actually see world models in action? One major use is in robotics. Imagine training a robot to carry fragile items in a warehouse. Instead of risking breakage, engineers use a world model to simulate thousands of scenarios, like dropping a box or bumping into a shelf. The robot learns from these virtual mistakes without damaging anything. The robot learns from these virtual mistakes without damaging anything. Another application is in video prediction. Some AI systems analyze security footage and predict what happens in the next few seconds. This helps detect unusual behavior early, like someone leaving a bag unattended. Self-driving cars also rely heavily on world models. Tesla's autopilot, for example, builds a live 3D simulation of surrounding traffic, predicting how other vehicles will move. These aren't futuristic dreams, they're happening now. And as models get better, we'll see even more applications in healthcare, education, and smart homes. Let's try a hands-on activity. Find a 10-second video, maybe someone walking toward a door or pouring liquid. Play it. Then pause and write down what you think happens in the next 5 seconds. Now, ask yourself, how did you make that prediction? Did you imagine the person opening the door or the cup overflowing? That's your natural world model at work. You didn't need data or code, you used experience to simulate the future. I did something similar, but with math and neural networks. This exercise shows that prediction isn't magic, it's a skill we all use every day. When you cross the street, cook dinner, or play sports, you're constantly running mental simulations. AI is learning to do the same. By reflecting on your own thinking, you're building a stronger intuition for how intelligent systems operate. Let's quickly recap what we've learned. First, a world model is an AI's internal simulation of its environment, its way of imagining what happens next. Second, it's essential because it allows AI to predict and plan, not just react. Third, it works in 3 parts: encoding input, predicting changes, and decoding future states. Fourth, it's used in real-world systems like self-driving cars, robots, and game-playing agents. And finally, it's learned from experience, not coded by hand. Remember, a world model isn't a rule book, it's a learner. It gets better over time, just like you do. By understanding this, you're now equipped to explore more advanced topics like reinforcement learning and autonomous decision-making. You've taken a big step toward demystifying how AI thinks. Before we wrap up, let's clear up some common mix-ups. First, a world model is not a list of if-then rules. It's not programmed, it's trained. The AI learns patterns from data, just like you learn to catch a ball by practicing. Second, it doesn't need perfect information. In fact, it handles uncertainty really well. For example, it might predict a 70% chance a pedestrian crosses the road, just like a weather forecast. Third, world models aren't just for fancy robots. Even simple game bots use basic versions to simulate moves. So remember, think learner, not instruction manual. Think probability, not certainty. And think scalable, not only for experts. These clarifications help you avoid confusion as you dive deeper into AI topics. Time for a quick check-in. Can you explain in your own words what a world model is? Try saying it out loud. Now, think of an AI system that would fail without one, like a self-driving car that can't predict pedestrian movement. Finally, how is this different from simple pattern recognition? Pattern recognition identifies what is like spotting a cat in a photo. A world model predicts what will be like imagining the cat jumping onto the table. Getting these distinctions clear helps you truly understand AI intelligence. If you can explain this to someone else, you've mastered the concept. Take a moment to write down your answers. This reflection strengthens your learning and prepares you for more advanced topics. Now that you understand world models, where should you go next? If you're curious about how AI trains in virtual worlds, Explore reinforcement learning with world models. It's a powerful combo that speeds up learning. For a deeper dive, look into latent dynamics and sequence modeling, which explains how neural networks predict transitions in compressed spaces. You'll also benefit from studying related areas like neural networks, the engines behind these models, and autonomous systems, which apply them in real life. As for resources, try beginner-friendly online courses, books on AI basics, or coding notebooks using PyTorch or TensorFlow. Join communities like our machine learning to discuss ideas. The key is to keep building step by step. You've laid a strong foundation. Now you can go further. To really master this topic, try these practice ideas. First, make it a daily habit. Notice when you simulate outcomes like judging whether soup is hot before tasting. Ask yourself, what mental model am I using? Second, try a small project. Use Python to predict the next item in a sequence. It doesn't have to be complex. Even guessing numbers or letters builds intuition. Third, join a community. Platforms like Reddit's are machine learning or a Discord groups let you exchange ideas with others. Teaching what you've learned is another great method. Explain world models to a friend or post a summary online. The more you engage, the deeper your understanding becomes. Learning isn't just about consuming content. It's about doing, sharing, and reflecting. Let's do a final check. Can you explain what a world model is without looking? Great. Can you name 2 real-world examples where AI predicts the future? Even better. Do you see the difference between an AI that only reacts and one that plans ahead? That's key. And finally, could you sketch the 3-part cycle encoder dynamics model decoder on a whiteboard? If you can do all this, you've mastered the core ideas. If not, that's okay. Go back and review the slides that felt unclear. Learning is a journey and you're making progress. Every expert was once a beginner. Celebrate how far you've come and keep building from here. Congratulations! You've just unlocked a key idea in modern AI, the world model. You now understand how machines simulate their environment to predict, plan, and learn more efficiently. You can explain this concept in simple terms, apply it to real-world examples, and distinguish it from basic AI systems. This isn't just theoretical, it's the foundation for technologies shaping our future. Whether you're interested in robotics, self-driving cars, or intelligent assistants, you now have a clearer picture of how they work. Keep asking, how does that think? And you'll keep growing. Thank you for investing your time in learning. Share this knowledge, stay curious, and keep exploring. The world of AI is vast, but you've taken a confident first step. Well done.